So the last thing I want to cover today are usage considerations for Java ReentrantLock. And a couple things to note: a ReentrantLock must always be used using a fully bracketed protocol. And that's just a fancy way of saying that the thread that acquires a lock must be the one to release it, just like the airplane restroom protocol we talked about before. This is actually known as the scoped locking pattern, which is a pattern I documented again about 25 years ago. You can read about it in the Posted To book, or you can take a look at the link at the bottom of the page. And this is implemented in Java by using a try finally block. You can also do the same type of pattern implementation by using synchronized statements or synchronized methods, as you can see here. That's part of the Java built-in monitor object, which we'll cover later in the course in more detail. This pattern is also used in languages like C++ or C# that have constructors and destructors that are called when a scope is entered and an object is created, and then when a scope is left and the object is destroyed. And this is a very common idiom in C++ and C#, and it's actually given a name. It's called resource acquisition is initialization. And so if you take a course on C++, they'll hopefully teach you this. I certainly teach it when I teach the CS 251 course at Vanderbilt. And here's a simple example of using what's called a lock guard with standard C++ to ensure a lock is always acquired when you enter a critical section, and then released when you go away. ReentrantLock supports the so-called recursive mutex semantics, where the lock can be acquired multiple times by the same thread without having to worry about deadlocking on itself. So go back and rewatch the video on that if you need a refresher, or take a look at the link at the bottom of the page. So ReentrantLocks are fairly efficient. They're fairly simple, but they can also be tedious and error-prone to program due to a number of common traps and pitfalls. So one common trap is to hold the lock for a lot longer than you need it, thereby keeping other threads at bay when they could actually make forward progress and run concurrently. So a simple example of this would be having a method, some method that acquires the lock, and then has a long-running for loop that does something that doesn't involve the lock, but you've held it over that whole duration, and that locks out other threads from being able to make progress.
Professor?
Another mistake, very easy mistake to make, is to acquire a lock and then return or have an exception thrown and forget to release the lock. And that means the lock may be locked indefinitely, and it'll definitely cause problems. Even if it's a recursive lock or a recursive mutex, it'll still get you into trouble. That's why it's so important to always get in the habit of using the try finally idiom in Java, to ensure that no matter how you leave, be it an exception or a return statement or a break statement or whatever, that the lock is unlocked on the way out. Another mistake is to unlock a lock that was never acquired or has already been released. Now, this particular code, you'd be like, why would you ever do that? Well, you probably wouldn't do this. But if you have complicated parts of your code that have if statements or switch statements and whatnot, you can sometimes get lost in the nesting of the logic, and there may be paths through which something is released but never locked in the first place. Another mistake is to acquire a resource without acquiring the lock, or access a resource without acquiring the lock for it first, or to access it after you've already released the lock. So that'll lead to race conditions and all these other hazards we've talked about over and over again. And then another subtle bug, which we've talked about in our frequently made mistakes videos a number of times, is to call the lock operation within the try portion of the try finally block. You don't want to call lock within try. You want to call lock before try, because if something goes wrong with lock and it throws an exception, you don't want to be unlocking an object that may not have finished being initialized. So that's the end of our discussion about Java ReentrantLocks. Hopefully at this point, you'll have more than enough information to do well on upcoming quizzes, not today's quiz, but upcoming quizzes. And you'll also have enough information to be able to do assignment 2B when it's released as well.